All right, 6.3 has to do with functions, and I know we've been talking about a lot of different representations of functions. We've talked about representing them with words, with equations, with input-output tables, mapping diagrams, and also graphs. But today we're just going to focus on what a function actually is. Okay, and more specifically, we're going to talk about linear functions. So a linear function is a function whose graph is a non-vertical line. Okay, and a linear function can be written in the form of y equals mx plus b. We've talked about a bunch, where m is the slope and b is a y-intercept. So basically, a linear function makes a line. Okay, so if here is my graph, I'll do a couple examples. Here are my three graphs. This is a linear function. It is a line and it is not vertical. Okay, this is also a linear function. Okay, it's a line, a straight line, and it's not vertical. And it can also be something like that. Okay, so linear function, remember, it makes a line. So example 1 says use the graph to write a linear function that relates y to x. Okay, and that's just a fancy way of saying write an equation in the form, or excuse me, write a function in the form of y equals mx plus b, where m is your slope. Does this sound familiar? Where m is your slope and b is your y-intercept. Okay, so first thing you have to do is find the slope. It's really hard to draw straight lines. But all you really have to do is you have to rise and you have to run to find the slope. So I'm rising, I'm picking any 2 points. I am rising 1, 2, 3, and I am running 2, which makes my slope 3 over 2x. And then I look for where the graph crosses the y-intercept, and it crosses at 0, -3. So it's going to be y equals 3/2 x minus 3, and that would be my function. Example 2, you need to use the table to write a function in the form, also in the form of y equals mx plus b. Okay, except for this one, you can't find the slope by rise over run. Remember, we also said that slope can be the change in the y's over the change in the x's, and this is where those carets are going to come into play. Okay, so the change in y, I'm subtracting 2 each time, and the change in x, I am adding 1. Okay, so my change in y is I'm subtracting 2, so I put -2, and I'm adding 1 for my change in x, which makes my slope -2. Okay, so this would be y equals -2x. Then I need to find my y-intercept. I can either do that by looking at the table or graphing it. I'm going to go ahead and graph it so you can see the visual. So this would be -3. Sorry, I don't know what happened. I need to go to -3, 9, which is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's my first point. Second point is -2, 7. Third point is that's not -2. -2, 7. My third point is -1, 5. And my fourth point is 0, 3. Okay, so if I connect these dots, it intersects the y-axis at +3. So my equation, my function, is y equals -2x plus 3. So these are on your own problems. So pause this video right now and complete these 2 problems. When you're finished, hit play, and I will have the answers shown for you. Alright, here are the 2 problems you just did. The first one on number 1, I had to find the slope by rising and running. So I rose -1, I ran 2, which makes my slope -1/2. And my y-intercept, it crosses the y-axis at -1. So this is y equals -1/2 x minus 1. On 2, I have to use the change in y over the change in x. So the change in y, it adds 0 every time. It doesn't change. And the change in x, it adds 1 every time. Okay, so change in y is 0. Change in x is 1. 0 divided by 1 is 0. Okay, so this is y equals 0x plus 2, which really just simplifies to y equals 2. Okay, and the way I found this 2 right here, the y-intercept, is when x is equal to 0, y is equal to 2. So it's going to, if x is equal to 0, y is 2 right there, and that would be my y-intercept. Alright, so example 3 says you are controlling an unmanned aerial vehicle for surveillance. The table shows the height in thousands of feet. That's important later, remember that, of the UAV X minutes after you start its descent from the cruising attitude. So write a linear function that relates y to x, interpret the slope and the y-intercept. Now obviously I forgot to copy the table in your note packet, so this is the table that you're supposed to be referring to, where it has minutes and height. So it says write a linear function that relates y to x, and keep in mind that's y equals mx plus b. Okay, so I need to find the change in y over the change in x to find the slope. And I notice that I am decreasing by 5 each time and increasing by 10 minutes. So my slope is negative 5 over 10, which simplifies to negative 1/2. Oops. Which I can also write as negative 0.5. Okay. My y-intercept is given to me in the table. Remember, when the x is 0, the y-coordinate, that is my y-intercept. So this would be y equals negative, I don't know why I keep doing that, negative 0.5x plus 65. Okay, now part B says to graph it. Remember, when you graph a function, if you're not counting by ones, you need to label and tell me that you're not counting by ones. So this one I'm going to, oh my goodness. This one I'm going to go by tens. So this would be 10, 20. It's too small. Hold on. Alright, sorry, I just went ahead and paused it and just labeled my graph. I went by tens over here, skipping every other line, and then went by tens going up. So the tens going across are my minutes, and then the height is going up. So my first point is 0.65. So I'm going up to 0, or excuse me, 0 and up to 65 and making a dot. And then 1060. And my next point is 2055. And then 3050. And then connect those dots as best you can. And you have graphed a linear function. Okay, so the next part of the question, part C, says to find the height of the UAV when you stop the descent after 1 hour. So keep in mind, in our table, our time was in minutes. So 1 hour, we're going to have to convert to 60 minutes. Okay, so when we're solving this, we're going to use our function y equals negative 0.5x plus 65. I'm going to plug in time of 60, so I'm going to get y equals negative 0.5 times 60 plus 65, which negative 0.5 times 60 is negative 30. And negative 30 plus 65 is positive 35. So y is 35. The main thing to remember here is y is in thousands of feet. Okay, so y is not equal to 35. That wouldn't make sense. Okay, if you're talking about height, height is not going to be just 35. It's going to be, I'm going to write it up here, 35,000 feet, because y is in thousands. Okay, that was part C. Last example is example 4. We need to compare these linear functions. And once again, I told you that the table shows, and then I forgot to copy the table. So if you will quickly copy this table, you can pause it while you're doing it and then resume when you're finished. But after 1 hour, the employee makes $12.50. This is the daytime employee. After 1 hour, she makes $12.50, 2 hours, $25, 3 hours, $37.50, and 4 hours, $50. Okay, so that's the daytime. The nighttime employee works X hours, and it's represented by y equals 7.5x plus 30. Okay, so 7.5, they tell me in the problem, is the slope. Okay, so this slope is her hourly wage. Okay, so now I need to figure out, I need to write a linear, first of all, who has the higher hourly rate? Well, after 1 hour, the daytime employees making $12.50, and the nighttime employees only making $7.50. So the employee with the higher wage is definitely the daytime. So daytime has a higher wage. All right, part B says to write a linear function that relates the daytime employee's earnings to the number of hours worked. Okay, in the same coordinate plane, this part you may cross out because I didn't give you graph paper. Okay, you do not need to graph these graphs. Okay, so all you need to do is write a linear function, and after 1 hour she earns $12.50, 2 hours she earns $25. So the change in y is $12.50, and the change in x is $1. So my slope is $12.50, which would make my linear function y equals 12.5x. And I believe that is it for this section. It is. See you tomorrow.